So yesterday what we saw was a cyclone by name Giri, which was October 2010. I showed the imagery on INSAT satellite, and it was having what you call all the patterns which are expected from a normal cyclonic storm. This particular image is very much useful for identifying the cyclone fury, etc. And to my knowledge and belief, this particular cyclone was having the cyclone intensity number of 5.5, and it crossed the Myanmar coast and caused a lot of havoc and damages because of highly sustained wind speed of 105 knots, maximum sustained wind speed. The next slide, which I wanted to show, again, internet slow or it's taking its own time. I had to advance the slide. Yeah, next one is over the Bay of Bengal alone. So this only area I was just showing that only got disrupted. This cyclone by name Thane, which crossed little south of Chennai, and this cyclone on the left hand side imagery you can see imagery taken by aqua satellite, and the right hand side is the cloud effective emissivity. Both are revealing the eye of the storm, and the cyclone furies, cyclone signatures very nicely captured. These sort of what you call very high sensitive resolution imageries are helpful in identifying the cyclonic storm, especially for the disaster management point of view, and alerting the common public as such. Then a cyclonic storm over Arabian Sea by name Nilafar. This also was having a very high intensity number 5.5 with a maximum sustained wind speed of 105 knots. After this particular time of what you call capturing the imagery, it started weakening drastically, and ultimately it not even crossed with any cyclone signature over the Middle East. It ended up as a low pressure area. The reason being, I have highlighted in red color bulletin down below. Due to the prevalence of high vertical wind shear, normally a cyclone will be having the affinity for low vertical wind shear as a great cyclonic parameter. And whenever high vertical wind shear is there, probably the cloud mass will go up, and then thereby the cyclone intensity will be diminished, and then it is trying to weaken as such. Then the entrainment of dry and cold air, which also caused what we call dissipating signature for the cyclone. And in addition, over this particular area, the ocean is having somewhat cold pool. Whenever a cyclone, which is a warm core system, entering into the cold area, it tries to weaken out. So these are all the reasons why very high intensity cyclonic storm of 5.5 ended up as a low pressure area over ocean itself. Most likely over this particular area in the Arabian Sea, any other storm they will try to weaken as such. Now we are going to other product generation and application from the satellite data. It is about the ocean surface wind. Surface here we mean it is almost similar to what we are having over the land area, 10 meter above the surface area. The first and foremost of its kind, which was quite useful by the meteorological community, was a satellite launched by QuickSat by NASA, Giant Propulsion Laboratory of NASA. So it was having a very fantastic spatial resolution of 25 kilometers, and it carried an active sensor as a payload that is nothing but a Ku band radar at 13.4 GHz. So this active sensor, as any normal radar does, it emits the radiation, and then from the target it gets the return signal. Only being the higher distance in the surface area, normally we are having up to some 500 kilometer surveillance maximum, usually around 250 to 400 kilometer surveillance. But onboard satellite, which is about 850 kilometer, that's why that low power alone is possible from satellite to emit. And then the low power signal, once it is reflected back, it will be further low, and then probably we have to do so much amount of juggleries to get a meaningful signal back, and then that has been done. With that, we will be in a position to get the signature, especially when the satellite is using a radar on board. So in this particular case, how the radar signal is coming in, it is nothing but oceanic surface. There are small capillary waves and then um, gravity waves of 1 centimeter order wavelength that is there, and then that reflects the surface. I will be covering this one in the next module also. So broad type of resonant condition that gets a signal back, and then that is being sensed by the on satellite KU band radar, and then with that ocean derived winds, especially over the surface, has been put. So this was launched in way back in '99. It was having a mission life of hardly 3 years, and then ultimately it has its own what you call life period up to 10 years. It served, and then during the last end or something, it had some problem, and then that also I am going to cover in the application part of it. So now the precipitating radar clouds and then aerosol which acts as a target, and then black resonance is a condition. Now over that, the ocean-side winds have been given by the QuickSat, and then that is a success story. I will be covering much more in detail later on. And so succeeded by SCAT by MAP satellites by EMETSAT, and then OceanSat ISRO from India, and Haiyong 2A from China as the successors. And other than the active sensor, probably some other thing like a passive radiometer also has been thought of by the naval group, naval defense naval group, and it is ongoing. It's on the cards rather. Right now, only active sensors are used for ocean surface winds. Maybe in the near future, we will be getting even the passive sensor also. There are some things sensors are getting working on now. So this I covered now, and then QuickSat mission life 3 years. It worked up to 99. That is 1999 to 2009, 10 years worked, and then only later period when we were having a cyclone by name Bijli in April. So we had a problem. We in fact interacted with some of the known persons from NOAA, NASA, etc. Then ultimately it was accepted by June or something like that. QuickSat had some problem, and then ultimately got decommissioned sometime November 2009. So this is about the QuickSat wind for a cyclone which I am talking about, Bijli cyclone, and then the center, etc. Probably now through the whirling circulation, you will be in a position to estimate. It was by and large all right in regard to longitude, and then latitude wise, it was out by 1 degree, 2 degree, 3 degree, and the last case it was even out by 5 degree latitude. That says that the center of the cyclone storm was misplaced by about 500 kilometers or so, right? From 100 kilometer difference up to 500 kilometer, the cyclone positional accuracy was there. So this we could not use in the operational setup, and prior to April, we were using in the operational setup also. And then this is due to the aging and then mechanical wear and tear could be the reason, and then that is what exactly confirmed by NOAA group in the month of June. And then there was what we call a bearing problem in the motor, and then antenna is not getting rotated, so on and so forth. All the technical issues were there. So this again, double accuracy is more different. It's what I would say. And then with the scale meter wind, I am closing out. Then as the product generation, because we are still in the image interpretation and product generation, the microphysics which are put in terms of red, green, and blue color RGB code, and then the first one we are going to take up is severity of EMETSAT, spinning enhanced visible and IR imager. This particular what you call product sensor, and then the data from that and derived product, they are useful for convective clouds especially. And the display is appealing the way in which we want to interpret. So red color is normally, that is by and large, all the satellite launchers will be using the same way. Red color is used only for the brightness, and then about the thick color, the convective clouds, and then clouds which are having high liquid water, ice contamination, ice, something like that. The green color, which is purely on water ice, and then a mixed phase of it. And then blue color is about revealing the temperature of the cloud top, and then the usual IR form. So we have both the satellite is having the surveillance on both the day and night. That's why the day and night microphysics, that's of much use, and then we are supposed to have different concepts in identifying. Otherwise, the earlier scenario of 1980s and 1990s, when the NOAA was transmitting the black and white type of what you call picture, and then we are also having the processing capacity in the ground receiver only with the black and white, and then that is having its own what you call advantage as well as demerits as such. Now we are having more number of channels, more information, and then thereby by plotting appealing colors which are very much useful for us, the green, blue, and red, etc. So we can have a distinction between ice and water, and then various phases of what you call microphysics happening within the cloud dynamics. And in addition, even where the water is of the smaller size, ice is of small size, big size, large size, small ice, etc. In addition to that, especially for the transportation purposes, let it be surface transportation or aviation. So the fog, which is the culprit on hampering and then causing a problem in deteriorating visibility, especially for the takeoff and landing operation over the airport. So fog monitoring and then fog detection, for that also this set of what we call RGB microphysics that will be of much use. So this is about the same CVD. What I was saying, what are all the channels which are used? The visible in red color 0.8 micron they were using, and then that is contributing mechanism is almost like thick clouds as well as the high liquid water. In the black color, I have given what INSAT is using. INSAT in India, we are using 0.8 micron, which is used by EMSAT. We are using 0.64 micron for red color. And for green color, the mid IR we used to say, and then this green color 3.9 micron, which is for both solar and terrestrial radiance wavelength, and then probably it is to distinguish between the particle size and the ice phase and water phase, and then discriminating between these two. In India, we are using shortwave IR 1.67 micron for this particular purpose. Then coming to the blue color, which is IR, the window channel 10.8 micron, most likely 10.5 to 12.5 is the window channel, and then most of the service providers will be using the blue color. So here the dark blue or deep blue, whatever language you can call, are high blue and low blue. So high is the thickest blue, dark blue, we will say in that way. Very warm temperature, probably know where we are, which color we are supposed to have. Normally the red also starts from a pale red or orange pale red, etc. It goes to the deep red. The same way blue also has a sky blue, pale blue, something like that. It goes up to the deep blue. So warmer the temperature, so we are having a high blue color, and then colder the temperature we are having very light in color. This is what EMSAT is using. So in a nutshell, in this particular tabular column, which has been downloaded from their website alone, and then I am just showing to you the red color channel, which is the visible channel 0.8 micron, and then green is 3.9 micron reflectivity, and okay. So then probably there is some other notes, and then that was for somebody else. I am not for it. That's why I was looking at. Then IR channel of 10.8 micron, which is the temperature revealing. So normally the visible is the reflective nature higher, and then more reflection will come only from a thicker cloud with high liquid water concentration. And the 3.9 micron, which is out the ice water contamination, and the reflective higher when contamination is high. And the cold cloud probably, which is extending beyond 10 kilometers, 12 kilometers, that is another issue, and then that is being depicted by blue color on window channel 10.8, 10.9, that sort of micron, whatever the launcher is providing. So with the black and white, what we are unable to distinguish, that is ice phase and water phase, etc. With the color age enhancement technique, that is color enhancement technique, we are in a position to say. And in addition, we understood somewhat relatively the physics behind it, and then that is why it is called as day microphysics and night microphysics. Different service providers are using different concepts, and ultimately it ends up with this one. Only the channel wavelength or wave number, that is different. That's all. That is the only thing, and then that also matters a lot. And then with that only probably we are surviving now. Now coming to the Meteosat second generation type of thing, and then I am just giving a view graph on two slides. This one and the next one. One is for the thundercloud, another one for the severe local storm, which covers right from hailstorm up to cyclonic storm. So what is the difference between these two? I have just underlined for that sake, so that in the offline mode you can download the PPT and then you can understand yourself when I sleep. That alone is difference. So red color, high red color in ice phase, mixed phase of water and ice, and then water phase everywhere. High red color, it is remaining constant. It is the large reflectance from 0.6 micron, which is used by Meteosat second generation group for identifying the thundercloud, whether it is the daytime or nighttime. Probably it is going to be the same, but nighttime you are not having the visible radiation. That is why that is not applicable for night. Okay. So now coming to the low green, which has been put in second of each of the row, maybe you can very well see that low green, which reveals large ice particles, and then mixed particle, maybe the mixed phase, and then if it is a pure water phase, the low green will be coming from the other effectivity. So that is what this has been just a compare and contrast. Only with the experience we will be in a position to decipher what exactly is relevant. In the offline mode, you can very well read very nicely. So in regard to the ice which is coming from the IR band, that way probably that is 10.5, 10.8 micron. The low temperature, the low value which is revealing the cold in this particular first column phase, and then the second one is cool, relatively warm, and the next one is warm. So this you can compare with the severe low storm case. Probably wherever the difference is there, I just underlined it. And then this is the area probably if you want to distinguish between mixed phase and water phase, especially on the green channel. So just as an example I am giving you, in the mixed phase of ice and water and pure water. So you can just see the green color alone. High green is talking about small water drops. Okay, so the high value of reflectance is coming over from somewhere here. Whereas if it is purely only on blue color or something like that, if you see that it is relatively warm. So the high value of what you call green, which if you go back to the earlier one, the low value was saying a mixture of ice and droplets, which is appearing on the same wavelength channel. Okay, so the low is underlined here. Here you are underlining a high value of green. So if you see a low value, what is the meaning? If you see the high value, what is the meaning? That is why in a nutshell, this particular tabular column gives you an information. So it requires a sufficient amount of experience, and then probably if you just contrast, you will be in a position to decipher, and then the next line I'm going to give you what exactly I mean. Today itself that will be covered. So the same logic can insert our cloud imagery, the left hand side and right hand side.
Check your internet connection. Professor Suresh, your video as well as audio have stopped. So you may either stop and then come back again, or click on audio video once they will stop and then restart again. Professor Suresh will come back soon. He has turned off his videos and he will turn it on again. Or maybe he will turn on the internet itself again.
Yeah, I come out.
Please bear with it. Yeah, he's coming back.
I am doing all juggleries to tide over this technical crisis. Even then, probably we will not be missing out that way. So the fog identification, as such, we were discussing about, and the left hand side and right hand side microphysics used by INSAT by ISRO group, and then IMD is the breadwinner for that, and then we are using it. Now coming to advanced baseline imager and microphysics from the satellite. So here they are making the difference between the 10.3 micron and then 3.9 micron. One is the IR in window and another one is the mid IR. So that particular difference, probably different concepts or different groups are using it. So the red color probably know the difference between 12.3 and then 10.3 is used for identifying the cloud thickness, and then thicker the cloud, probably the low positive to negative values, the difference will be there, and then that can be reflected in different shades of red. In the green color, the 10.35 micron channel array is from there, from that 3.9 is subtracted, and then that gives the contamination of ice over water, and then it's a mixed phase, and then that gives what are all the value, etc. It gives about the positive value, it's talking about the water cloud, and then probably over the land, and then ice cloud, if it is there, it should be the negative one. And 10.35 micron alone, that is purely on IR, that is the window channel, and then it talks about the temperature of the cloud tops. The same picture which we saw earlier, now probably with the microphysics which is applied, and then you are able to see that instead of the earlier whatever we saw, this color is somewhat really appealing. The forecaster which is tuned for this set of what we call identification, especially the color enhancement technique, he will be in a position to say that thick fog is engulfing over the northern pocket of India, and then over the it is towards the foothills of Himalaya, etc. We will be in a position to differ. These are all the snow crystals, and then very we can well say it is a Himalayan, and then the snow, and then patchy type of ice crystals. Last week internet was very fine, and then probably I have some problems since yesterday. Yesterday also the same thing has happened, and then today it's also happening. Though
Turn on again. Professor Suresh, please turn off your video and audio and restart. The internet at the end of Professor Suresh is breaking today, and because of that there are interruptions. You may, Professor Suresh, you may go to that hotspot of your mobile if you have not done that already. Please, participants, please bear with it. He should be returning back either with the same internet or he will change his internet link. I have made suggestions in the chat box that if your screen is covered partly by the video of the speaker, please take your cursor on the video, and you will find that there is an arrow. If you click on that arrow, the video will get out of the presentation area. The PPT and video of all the 3 talks that have taken place in this series have been uploaded, and you may take advantage of those. The links are on the Space Education and Research Foundation website, which is http / double dot and slash www.ser.foundation. I had given this link on the chat today also and yesterday, and it is there in your invitation as well. The problem seemed to be more today with him. Let's see if he comes back. Already he's still doing the remaining part of yesterday's talk, and I think there are 2-3 more slides that he had to cover, and then he will start today's talk. But it is getting difficult with the internet breaking so much. I don't know what we should do. Please wait for him to come back if he can. Let me see. Let me try to call him on phone. Yes, he's coming. He's just going to be online. Here it comes. Yeah, please start. Your video is coming, but audio is not coming. Professor Suresh, please turn on your video. Your video is on, all right, but audio is,
yeah.
yeah.
Okay, I turn it on. Right.
Yes.
So the geostationary platforms, they give you the GPM height and then precipitable water over different layers. Then in addition to that, especially for the forecast point of view, they lifted some amount of what we call instability indices, what we can normally do derive physically based on the reason and GPS and data. So satellite is providing us now on a spatial platform straight away, whereas in GPS and it may be applicable only for the station concerned. Suppose I calculate for Delhi, it is applicable only for Delhi and around, whereas the satellite is giving throughout India as such. So in addition, there are some indices which are useful for predicting thunderstorm, microburst and other things. So that's also available nowadays. And about the convective instability through equivalent potential temperature. So that also is applicable. So nowadays, we have empty number of products. I think we should be in a position to use it in a proper spirit, and then how best we'll